Yes, Satish. So
Yeah.
let me just repeat the question before we get started.
Yeah.
The question is, you have a matrix of booleans. You want to find the biggest submatrix where all the values are true. And biggest means maximum area, width times height.
And the biggest submatrix with true values.
All true values. Yes.
Includes height with
Height times width.
height times. So I'll create a sample input static just to understand.
Sure.
So let's say it is true, false. So here, this will be the biggest submatrix static. The from 0.
Right, first two columns.
Got it. So my output should be in the format of so should I print the index values or should I just return the submatrix, I think, the first two columns?
Anything, or you can return the area. In this case, you can return 8 as the result.
8. Okay, this is the maximum. Got it. Okay. Got it. Understood. Everything is clear. So the brute force or naive approach I can think of is basically create all the submatrix like 1 cross 1, 1 cross 2, 1 cross 3, all those values. Then once you got all the output, for example, true, like this, then finally I will have all the values. Then okay, because this is a m cross n matrix, I need to handle this value also.
Which value also?
Like this, Karthik. Let's say it has like this. So I need to do. Am I clear, Karthik?
Yeah, basically every possible width and height combination you have to check. Which could also be 0 by 0 if the given matrix consists only of false values. Or the entire thing if it consists of true values only.
Got it. Okay. First of all, I need to iterate through. Okay. Okay. So to iterate through the input array, I need to do 2 for loops. So first of all, I need to. So let's say a simple matrix with 2 cross 2. 2, 2. I need to create an output array of 2, 2, then 3 trues, then so this will be my naive approach. Then finally, once I create the output array, I'll go through, and since all, as per my logic, all these submatrix will have only true, I will find the highest length and I'll return it. But how to do this? Okay. Karthikeyan, what I'm doing is currently I'm just iterating through the matrix, the 2D matrix, the 2D array, just to get the values.
Okay.
So if I find the if input of I of j is true, then I will create some submatrix logic, then I will push those things.
So what does true mean? Oh, you're checking only the value of I of j. Okay.
Yes, Karthik. Okay, so 1 cross 1, then 1 cross 2, then 1 cross 3, then 1 cross 4. Just need to create two values of maybe. So what I'm trying to do is basically as 1D array, 2D array, 3D array, all will have whatever has true values. I'll put it in my submatrix, and finally I'll find the length. That's what I'm trying to do now. True,
So
true.
you will select all valid matrices consisting only of truths, and you will create a subarray of all those possibilities, correct?
Yes, Karthik. That's the idea.
So you'll never have any false value in your array of arrays.
Huh.
Got it.
Then finally I will just iterate through it, and I will just find the maximum length of that subarray, and I will return that value.
Okay.
Since every okay, now that's what I'm trying to do. Now okay, now I need to do a 1D matrix, then 2D matrix, then okay. Submatrix logic. First I need to do m, m. First I need to do 1 cross 1 matrix, then 2 cross 2, then 3 cross 2. Now I need to, okay, how to do this? So now I need to find this force up, the 0 cross 0 to 0 cross 3. That is the first column only is the true value. If I take only the true values into the submatrix, finally, as per my logic, it will become 7 since there are 7 true values. That won't work.
Let me ask you a question.
Okay, Karthik.
How much space will your algorithm take? It's a lot more than the input data, right? Because you are having different subsets of the input data.
Yes, Karthik.
How can we optimize the space? Assume we have infinite time. We don't care about time, but we have limited space.
In that case, Karthik, so as per my logic, even though I'm not able to find out that logic now, so it let's say my first array will have multiple single true values like this, Karthik. What I can do is I can create a hash map like this, and like one D array, and I can just put one true. Then if there is two, then so in this way, multiple 1D matrix won't get stored in the space.
So what's the space complexity of this?
It will be a number of 1, 2, 3. I'm confused. I'm not sure between M or N.
Assume both the width and height are n for ease of calculating the complexity.
In the worst case, it will be O of N.
So if this were a real interview at this point, I would say, take as much, and let's pretend it's a real interview in the rest of this conversation.
Yeah, I'm considering it like that only.
So I would say, right. So take as much time as you want when I ask you a question before you answer. There's no penalty for that, but there's a penalty for giving me the wrong answer.
Got it.
So now, do you want to revise your answer of O of n space complexity?
I just did something.
Sorry?
I'll take some time, Karthik, to think.
Yeah.
So number of rows it will be. In worst case, it will be Karthik, I think it will be O of n, Karthik, because in the worst case, I'll be storing 4 rows as per this input. So O of n.
So each of the keys can be n squared in each of the values in the hash map can be n squared in size, right?
Yes,
the worst case.
The value can be n size, yes. So
n or n square? So the input is n by n in size. The keys go from 1 to n. So for the key n, the value can be n square, right? If all of them are true.
All of them are true. Yes, Karthik. So yes. So 1 square, 2 square, 3, 4. Okay. Yes, Karthik. It will be of n square.
So
it will
be of n cube, because you have n keys and each of the values can itself be n square.
Here I'm little confused because the key will be 1 and the value also will be the same, right? So this will also be O of n, this will be O of n. So finally,
yeah. So basically, the worst case will be, so if it's a 5 by 5 matrix, it will be the time complexity will be 5 square plus 4 square plus 3 square plus 2 square plus 1 square, right?
Yes. So it will be
O. How much is that?
It is O of n square, right?
N square plus n minus 1 square plus n minus 2 square. What is the mathematical formula? I'm not remembering it right now.
No, Karthik, I'm not able to recall. It is
okay, fine. But fine. Anyway, let's assume we have no additional space available. You can't create a hash map. You can only create some local variables. You can't create a hash map or a list or an extra array. We don't have that much memory available.
Okay, got it. In that case,
How would you solve this? Yeah.
Ideally, in this case, in case of this situation, as soon as we find the largest submatrix with true values, we replace the old variable with that. So we can track the, for example, as per my logic, as soon as I find 1 cross 1 true value, I'll put it in my local variable. Then only I will.
The local variable will be a list or a submatrix.
It will be a. I just thought of like a. Initially I thought it like will be like a count, Karthik. For example, if I go through 1 cross 1 matrix and if I find true, initially it will be 0. And as soon as I find 1 cross 1 matrix to be 1, true, I'll put it as 1. Then as soon as I find the incremental numbers, I will change it. So I thought of it like a number count.
So you're not going to store the actual submatrices. You're just going to store the
Number
size.
of, yes.
Okay, fine. So let's write pseudocode for that.
Yes, Karthik, I'll do that. But the problem is, I need to consider the height also, width also. My iteration logic will only go, for example, how to, I'm just thinking out loud, Karthik. How to write a logic. Okay, so now let's say initially it is 0. I will find the 1 cross 1. Okay, I found a 1 cross 1 true. So there is at least one value, 1D value with true. So I will replace that count with 1. Then I will find the next. So there is a 2D matrix which has true. So now the count will be true. False. But I can't reset it because I need to go through this, which will form its own submatrix. Submatrix. Karthik, I have one doubt. Can I consider this first column and second column's first 2 rows, like 6 as true?
No, that's not a submatrix. No, it has to be rectangular. It can't be odd shaped.
Got it. So, okay. Now I need to find out a logic where as soon as I find false, I should not negate it because. Okay. So I'm iterating like this, then this, then this, but these 5 values are not, but so I need to just consider these 4. Cross 1, cross 2. How to find the submatrix logic? How to? Okay, I need to find few logic here. One is I should not stop the iteration as soon as I find false value. I also should be careful about odd shape. Okay, so I'm starting here. As soon as I find first true value, I'll increment it. Then, okay, I'll iterate it like this.
So in the interest of time, shall I give you a hint?
Yes, Karthik.
So the first thing I would do is I would try to find out how many degrees of freedom this has. And a matrix is identified by 4 numbers, xy, width, height, right? Xy is xy of the top left of the submatrix. So these are the 4 values I have to determine, correct, in order to determine a submatrix. Right? So
Yes. X and Y.
for any algorithm, sorry.
Gati.
So for any algorithm question, I would figure out how many parameters do I need to determine in order to get the solution. Since it's a rectangular, it has a x, y, width, height. So first I would try to figure out the degrees of freedom, which is how many independent parameters are there to determine for any problem. For example, if you have a string and I'm asking you to find a substring that meets some criteria, then it has 2 parameters, beginning and length.
Beginning and the length, yes.
In that case, it has 2 parameters, right? So in this case, there will be 4 parameters, x, y, width, height. So that is the degrees of freedom, right? Now, with that in mind, I would just be lazy. I would just write 4 for loops for x in 0 to n, for y in 0 to n, for width in whatever, right? 0 to n minus x or whatever, for height in, right? I would write 4 nested loops.
Okay.
Because there are 4 degrees of freedom to find out. And then what goes inside the loop? I would just assume there's a helper function called is submatrix valid, which takes 4 parameters, x, y, width, height, and it tells you whether that submatrix is valid, which means it has only true values.
Okay.
So you should think in terms of functions. You are trying to solve the entire problem at once and getting stuck. You need to break it into functions this way. Then it becomes easier for you to think.
Got it.
So I would write 4 for loops, and I would say if is submatrix valid, x, y, width, height, the area is width into height, right? And I would compute the max, and that's it.
Got it.
Now this helper function is also straightforward. I would just iterate over the given values and check whether all of them are true. It's a 2D iteration. So this is a template to solve any algorithm problem. It may be a bad solution, but it gets you to a solution.
Find
Identify.
Find the freedom of.
So the first step is find the number of degrees of freedom.
Just a minute. I'll just note it down. Find the degree of. Yeah.
Suppose there are a number of degrees of freedom. Then write a nested for loops.
Got it. Yes. Suppose a number.
Then, then compute a score for each of those. In this case, the score is 0 or 1. If all the values are true, the score is 1. Otherwise, the score is 0. Actually, in this case, the score is the area. If all the values are true in a given submatrix, the score is the area, width into height. Otherwise, the score is 0. And in different problems, the score computation may change. So for example, imagine it's a matrix of integers and we want even numbers. So in that case, the logic might change, right?
Okay.
So, but whatever it is, in general, you can compute some score. Higher the score, better the result. And then just take the max and assume there's a sub function for this. This is a way. It may not be a good way, but it's a way to solve any algorithm problem if you are lazy. You don't want to think too much. You want a ready-made solution. Or you want to give a quick solution.
This makes
because in an interview. Sorry?
No, I was saying that this makes more sense.
Yeah, because in an interview, it is important to come up with any solution quickly. Because otherwise, if you run out of time and you don't give even a bad solution, then your score will be 0 for the interview. Right?
Correct.
And the goal is to get to a non-zero score ASAP. Then you can improve it further.
Got it.
So yeah, so in this case, why don't you write 4 loops for X in whatever, for Y in, for width in, for height in. You delete all the matrices other than the input. One more tip is, in an interview, always write pseudocode first. Do not write actual code, because in this case, you'll stop and think whether it is M or N. So what I would do in an interview, and I adopted this strategy in an interview, and I passed in a real interview with Microsoft, which is, I would say, for X in valid values. The details you can figure out later. You want to give a template of a solution. Or if I would say for X in 0 to M, right? Like a for in loop.
X invalid values.
So think of it like an iteration, right? If you're drawing a picture, first you would draw it roughly and then you would refine it. Right?
Then, so the 4 values are, I need to calculate out width and height, and X and Y. For width invalid values, then height in valid values. So finally, I will have a help and function is valid submatrix, which will check whether all the values are true.
Actually, let's generalize it. Let's call it get score, which calculates a score. This will work for any solution, any problem.
Okay.
Get score X, Y, width, height.
Okay, got it.
And then of course you store it, you have a max value. If it is less, you update it, etc. Right? Right. So yeah, get score returns 0 if any of the values in the submatrix is false. Otherwise, it returns width into height. Right? You can just write this in the form of a comment. No need to code this up. Or if you want, you code it up. Either way. Yeah, let's just write pseudocode for that quickly.
Returns 0 if invalid, else returns height into width.
Wait. Just write pseudocode for this quickly.
Okay, got it. So basically, for the validation, I need to check X is lesser than or equal to width, and Y is lesser than or equal to height. And also I need to check all the values are true.
Yeah, you can assume the parameters are valid. No need to check those.
Okay, Karthik.
Like in general, while coding, it's a good practice to check the parameters. But in this case, since you are calling it, just to keep the code simple, let's omit.
Okay, Karthik. So here I'll get a submatrix, Karthik.
Yeah, X, Y with height, yes.
So I need to iterate through the submatrix and I need to confirm whether all the values are true.
Yes.
If all values are true.
Now write a loop like above, a pseudocode loop.
Okay, Karthik.
Because this will help you understand time complexity. If you say if all values are true, you won't know the time complexity of
it. Okay. So I need to iterate through the submatrix. So it will be, I need to iterate through m cross n. So it,
You don't even need to do that. You can say if input of n equal to false, return 0. The score is 0 because it is invalid. Otherwise, at the end of the loop, return width into height. So there's no else. Just finish the loop.
Okay, Karthik.
There's no counter. You don't need the counter variable. You don't need an else.
Got it, Karthik. Because as soon as we find the false value, we are returning it. So
Yes.
finally, we just need to return the height
Yeah.
value.
Now, what's the time complexity of this?
This will be, since it is 2 for loops, it is O of n square, Karthik.
No, the whole problem.
Whole problem.
Whole program.
O of n power 6, Karthik.
Yeah, that's terrible, isn't it?
Yes.
Now, how would you optimize it?
I'm just trying to think of some caching mechanism, whether I can do that. I'll try to see whether there is any repetitions.
Yeah, that's the right logic. To reduce the time complexity, you want to reuse some of the work that has already been done. It's very hard. I was asked this in my Google interview in 2007. I couldn't solve it. And recently, I spent more time working on it. I got it down to order of n cube, but that is not the optimum. The optimum is n square.
Optimum is n square. Okay.
Time complexity and space complexity also. So one thing you should think about is think about the recursive step when writing an algorithm.
Okay. Think about the recursive step.
If there are n steps, and suppose there are 10 steps and 4 steps are already done, how do you use the result of the first 4 steps or the 4th step to find out the 5th step?
Okay, Kathy.
Not do it all over again. So I'll tell you the answer. It's very smart. When I Googled it, I got a result from Geeks for Geeks. The idea is you create a scores matrix of the same dimension.
Okay, Kathy.
And if you index into the scores matrix at any particular value, it will tell you what is the maximum area of a submatrix with the bottom right corner at that position.
Bottom right corner at its position. Okay, Kathy.
So scores of ij will be the area of the biggest submatrix whose bottom right position is I, j.
Okay. I'm not able to visualize perfectly, but I'm getting some idea. I'll definitely look into it after our discussion. I'll concrete.
Yeah, no, I'll tell you that's okay. I'll tell you that's okay. So this is not a real interview. This would take hours or days. But the solution, the optimum result, it will have some bottom right position, right?
Bottom right position. Yes, Karthik.
It has to be somewhere in the submatrix or the given matrix.
Correct.
So now suppose you find out for all of them. So you say if the bottom right of the submatrix is 0, 0, you are putting that constraint. Then there are only 2 more parameters that you can change, which is width and height. So you try all possible combinations and you give it a score. Then you try for 0, 1, then 0, 2, then 0, 3, then again next row. All the values you try.
Once we exhaust,
and then once you are done filling this matrix,
the bottom
you just return the maximum value of all the elements in the matrix.
Maximum value of all the elements in the matrix. Okay. I thought the bottom right will be having the largest value. Okay. In the score matrix that based on bottom right only, we are handling all the cases. Like I thought finally after exhausting the height and width, that bottom right will have the actual value, I thought, in the score matrix.
No, you have to iterate over all of them because you don't know the ideal result. Its bottom right may not be the bottom right of the given array. Maybe that bottom right has a value false, in which case you would exclude that.
Okay.
So if you imagine a 10 by 10 matrix where the center values are all true, but the edges, last row, last column, first row, first column are all false. Then the submatrix will be 8 by 8, right?
Yes.
And the bottom value of that will be 8,
8,
8. So yeah, so basically the algorithm is very simple. You create this
score matrix.
You create this course matrix, and first row, first value, you copy them from the given matrix, right? If it is false, you make it 0. If it is true, you make it 1.
Okay.
And then you use this formula, scores of I, j. Just write it down.
Okay, Karthik.
Equal to min of scores of I minus 1 j. Scores of I j minus 1. Scores of I minus 1 j minus 1. And then after the parenthesis, plus 1.
After the parenthesis, plus 1.
Yes.
Okay.
So the basic idea is that you just check the 3 neighbors from any position. You look to the top, you look to the left, and you look to the top left.
Look to the top. Okay.
All of them have to be true. Otherwise, you cannot extend it. So suppose you have extended it till 3, 3, right? The bottom right. Now you want to check, can you extend it to 4, 4? How can you do that? You can do that only if all 3 of these values are true.
Correct.
3, 3, 4, 3, and 3, 4. Right? So just to repeat, if you know that you have a matrix of all true values whose bottom right is 3, 3, and you're wondering if you can extend the bottom right to 4, 4. The answer is you can extend it only if these 3 values are all true. 3, 3, 3, 4, 4, 3.
Yes.
If even one of them is false, it's gone, right? So that's why you're taking min and not max of these 3 values.
Okay.
So,
because
so now with this formula, it's, sorry.
No, Gati, sorry to interrupt.
Yeah, no problem. So now with this formula, you just write a simple for loop. I goes from 0 to n. J goes from 0 to n. Fill in all these values. Then write, once you're done with these 2 loops, repeat the 2 loops, and this time take the max, and you're done.
Got it.
In fact, you can even do it in the same loop if you want to. But basically, it's n square.
Yeah, Kati, because we are doing 2 for loops 2 times, but it's not nested.
Yes, exactly. So basically, for any recursive algorithm, you should think, if I've come some distance, how do I take the next step? Ideally in constant time. So this formula, for a given value of I, j, it's constant time. It's not iterating over n values. It's just comparing 3 values and doing 1 addition, which is constant time.
Got it.
So now, if you are taking n square steps, but each step is constant time, then it's an n square algorithm. So the ideal recursive algorithm would be like this. If the data size itself is n square, anyway, leaving aside some special cases, anyway, your solution will be n square because you have to examine all the values, right? You can't have n. But at least you can prevent it from getting worse, like n cube. And the way you prevent it from getting worse is for each step, it's constant time.
For each step?
It is constant time.
Okay, okay, got it. Yes, that's very important. Yes.
Anyway, I think we'll conclude here. How are we doing on time? Yeah, so anyway, so just to recall or summarize, given any problem in an interview, your first goal should be to find a solution, even if it is inefficient.
Okay.
And one way of getting to that goal quickly is to identify how many degrees of freedom are there. In this case, it's 4, x, y, width, height. And you just write one loop for each of them nested. And for each of those, you compute a score. And you just use the max of the scores. So this is like a lazy approach to solving any algorithms problem. Can be very inefficient. The optimum approach is to think in a recursive way. Like the code need not be recursive. This formula is not recursive, but your thinking is recursive. You are saying, I've already done 10 steps. How can I do the 11th step, ideally in constant time? And you have to figure out how to represent data. I knew this logic, but the reason I failed in solving this in n square is that in my scores matrix, scores of I comma j represented the top left of the submatrix, not the bottom right.
Okay.
So you have to figure out how to represent data. What do you keep? So when we said the result of the 11th step is the result of the 10th step with some formula, you have to figure out how to represent it. In this case, we're representing bottom right.
Okay.
And if you get that wrong, everything will fail. So anyway, I guess we can stop record. Or do you have any comments before that?
No, Karthik. This was really helpful. This cleared out. So generally, as soon as the problem statement is given, the steps I follow is get anxious about the problem. Second step is code right away. Now I have a structured approach. I always thought coming up with a bad solution is bad, but it's completely better than having nothing like I initially had. So the lazy approach I had, now you have mentioned it. Now I have a very good idea of how to, for example, any kind of problem, let it be submatrix or matrix, I'll just think about it in the pseudocode form. I'll find the solution, I'll find the degrees of freedom, I'll write code for those degrees of freedom. Then from there, I'll try to optimize in space or time. If it is space, we can, like you said, we can consider it like using.
Even before you optimize it, you should analyze what you have and determine, is this already ideal?
Got it.
People often rush into optimization without even measuring what they have.
Yes. Got it. This is very helpful. Hopefully from next time onwards, I'll apply these concepts on it.
Yes, and often the data size is bounded, in which case none of this matters. So for example, I worked on a Google search app while I was at Google. This was an app for a mobile phone, right? And for any query you type, you would show 10 results only. And we had to use some algorithm on the client side. You can use any algorithm. It just doesn't matter with 10 values. You can write an n-cube algorithm. Or an n-power 4 algorithm. It just doesn't matter, right?
Because
it's that small
will be written only 10 values in any case.
Yeah, so basically in the app, if you search for something, suppose you search bank, it sends it to the server and the server will return 10 results for that query. And now client side, you have to do some logic. I forget what it is. For that, you need to use some algorithm. But the efficiency of that algorithm doesn't matter because you have only 10 values.
Always it's bounded.
The server returns 10. Only 10. Yes. So,
got it.
My colleague at that time, just to finish, my colleague at that time said, hey, this is an efficient algorithm. And I told him it doesn't matter. In fact, like time complexity wise, higher time complexity may actually be faster
Hmm.
because only for big values of n square is lower than n. For a small value of n like 10, an n square algorithm might actually be better than an n algorithm because there's a constant factor, right?
Okay. Sorry, Karthik, can
So
you
basically, when we say an algorithm is n square, we are
Hmm.
saying the running time is k into n square.
Constant into n square. Yes,
Suppose k is 1
Karthik.
and n square is like 10 into 10, 100. So the total time is 100.
Yes, Karthik.
Now, suppose you have a linear time algorithm.
Oh, fine.
Its constant value may be 10,000.
Huh.
So it's 10,000 into n, which is 10, which is 100,000.
100,000. Yes.
So it's actually worse.
Hmm.
So yeah, so that is why it's important to always come up with a quick solution. You may not deploy it, but just to get started.
Got it.
And anyway, time complexity doesn't matter outside of interviews.
Got it.
Even at Google, I probably used it once in 4 years.